James here.
All right, we're going to learn how to balance our nuclear equations. Back on page 5 and 6 of your nuclear packet. All right, there are a couple of things that you need to remember that govern balancing nuclear equations. The first one is mass numbers are conserved. On A1, write mass numbers. Yes. Thank you. Mass numbers are conserved. What does that mean? That means the total mass on the left of the arrow must equal the total mass on the right. Or we'll just put total mass on the left must equal total mass on the right. Okay? The mass numbers, excuse me, the mass number equals the top number. Okay. Second part is atomic numbers are conserved. And charge is also conserved. Both of these can be the numbers at the bottom. Okay? All right. You're going to need your periodic table, so go ahead and get it out. And you will also be using the part of the packet on the previous page that you filled in yesterday. You will be using this right here where it says symbol of particles, where it gives you the symbols and their masses and their charges and stuff, okay? So that's what you'll be using, this column right there. All right. Now then, this is relatively simple. And if you treat it like math, where you are always just balancing your numbers, the numbers on the top left have to equal the numbers total on the top right, and so on. Same for the bottom. Okay. Now then, so on the top, on the left side of the arrow, I have 65 plus 1. What's my total?
66.
Now, you don't have to write this. I do when I'm teaching it to make you get it in your head. Okay? 30 plus 1 is a total of what?
31.
All right. Simple enough. Yes? Okay. Well, we get the whole 31 in whatever this is. So that tells me that this over here on the bottom has to be a what? A 0. Now, look on your periodic table and tell me who is element 31.
Helium.
Okay, the symbol is what?
Ga.
So I'll put Ga. Okay, it has an atomic mass of 65 here. So that means I need to put a what here? A 1, because 65 and 1 make what?
66.
Now turn over to the back of this page and look for the particle that has a 0 on bottom and a 1 on top.
Neutron.
On the back of your page. In your nuclear packet, look on the back of your first page.
Neutron.
Positron.
Neutron.
Turn this over and it's right here.
Yes, neutron.
That's neutron.
The one where we filled in all the symbols. Everybody see it? And it's the neutron. Okay? So that's basically how this works. It's extremely simple. Again, think about getting your math numbers to balance on each side, right? So 238 and 1 is what? 239. 92 and 0 is 92. All right. So I've got a 0 here, so that tells me I have to put what here? Say it again out loud. 239. Okay. Now then, I've got a -1 here. What number minus 1 gives me 92?
93.
So I put a 93 here. Now go look up element 93. What's its symbol? NP. Okay. Everybody hanging with me?
Yes.
Okay. Now this one has a little catch to it. It's still simple. Alright. So 252 and 10 is what? 262 and 98 and 5 is 103. Alright, so we've got our totals for our left side. Now then, go find LR and tell me what its atomic number is.
It is 103.
362. Oh, 103, you're right.
103. So I'm going to put that right there. So that means my bottom over here has to be a what? So I put a 0. Now then, what's the difference between 262 and 257? Okay, go look at your little chart. Is there any particle that had a 5 at the top?
No, ma'am.
No. That means, what else do you have that has mass on the top and a 0 on bottom? The neutron. So you default to the neutron. Now we're going to use a coefficient of what?
5.
5. So in other words, it produces 5 neutrons. Okay? Now, to get this to balance, 257 plus 5 times 1 is 5 gives us 262. And the 5 times 0 is 0, and it doesn't affect our 103. Everybody with me? All right. Now, it's your turn. Complete the assignment.
Yay! Kayla Tucker, have a blessed day!
Thank you, Caitlin.
No problem. I'm the best.
Not over.